Okay, so my name is Owen. I have been a mathematician for probably about 15 years. I've taught at a few U.S. universities, undergraduate and graduate education. I wanted to read this document, the Leiden Declaration on Artificial Intelligence and Mathematics, and just have a discussion, or at least have some kind of conversation reacting to what this declaration says. This isn't like a first read through. I've read the document already, although I was on a flight leaving Europe, so I didn't really pay full attention to all of what it said. But there were some things that I actually kind of thought were, I don't know, contentious, I guess. So I wanted to just read it and get my thoughts straight, I guess, on what the main points are. So if you don't know, this declaration calls for action to address the challenges posed by the use of artificial intelligence within mathematics research. It is the result of a community initiative and is endorsed by the International Mathematics Union, or Mathematical Union. Okay, the group of mathematicians is a very diverse group of people who don't necessarily agree on quite almost anything. Um, and even the fields of mathematics, it's not so clear, at least university. For example, like pure and applied mathematics, this tends to have a lot of discrepancy, and people and they fight a lot for funding. Also, statistics and mathematics, some institutions group these separately as different disciplines, for example, and a lot of maybe the differentiation comes from the hierarchy of just employment. So if you can draw on funding, this is good. You can often do that if you say you work on something like cancer, or if you're a statistician. It's definitely an employable field, or at least it was a couple years back, where you could maybe go into data science or actuarial sciences and so on. So let's see how this goes. I should clarify also that I'm a pure mathematician. So I work in a field called algebraic geometry, which is actually, I think, going to be up and coming. I think if you talk to a lot of, it's like a field that's been worked on for thousands of years. It's probably like one of the oldest fields in math. And if you talk to people, my general impression is that I think that algebra, linear algebra, and algebraic geometry, these are probably underrated fields. I think definitely there could be more education that goes into teaching algebra as a core discipline. Um, okay, so anyways, preamble. Technological developments have repeatedly transformed the practice of mathematics. Recent artificial intelligence technologies, including symbolic and neural methods for the generation and formalization of mathematics, may already have initiated a significant chapter in this long history. Among researchers, artificial intelligence has produced a wide range of reactions: enthusiasm for its potential to yield new discoveries, intimidation by the pace of its developments, indifference to these rapid changes, and concern for their implications, both for mathematics and wider society. And this is true, right? Technological developments have repeatedly transformed the practice of mathematics. Just the invention of calculators, maybe people don't know, but things like logarithms used to be something that you would look up in a book. So if you wanted to look up, what is the logarithm of 620, you would look at a book, and you would find the value for probably log of 6.2 something something something, and it would give you some decimal expansion. And then this is what you would use. Uh, there were also people that computed things like prime numbers in books. These are like pretty well known, or at least you can go look and you'll see. So the just transition of going from a science where you have computation and then tools that can do these computations for you, that's already one huge change, right? Obviously, computers, another big change, but these are changes that probably, I mean, basically every discipline experienced as well. So access to information, like Google search, this is a big one. not using a library. Definitely, I know professors that talk about mailing in their manuscripts or giving their applications to secretaries at their institution where they did graduate school to apply for jobs. That was something that was still happening for a lot of the people who advised me. Um, okay, and generally this is true too. I'm very enthusiastic about the potential for new discoveries. The pace of developments, I think, it it was very intimidating in the last couple of years. I don't know. I mean, I haven't seen a major model come out recently that's really made me shift my perspective of how the pace is now. So it's not clear. I think, are you in the exponential incline, or are you kind of actually flattening out like a logistic graph? Um, so it's not so clear if there's actually going to be, I think, a still quite rapid development. But if there is, that would be something to consider. Um, Indifference to these rapid changes, that is probably a fading reaction, just because of in mathematics, there's still a huge trend, especially in pure mathematics, to just completely reject technology in a lot of ways. Like when people do research, it's pen and paper, no use of computers or computation or calculation tools. And you could think about this in some sense as a reaction to just the translation from, um, having a computational field and then all of a sudden maybe having calculators or having quick access to this. Some people value the work that does not rely on kind of those computational tools, and so they focus on those aspects of the work that they can do by pen and paper. Okay, and I don't want to spend as much time on every paragraph as just this one, but yeah, especially because I know this is quite a long document, but I do want to at some points pause and just bring some things up. So mathematicians have a choice about whether and how to adopt artificial intelligence in the conduct of their research. They also have a responsibility to ensure the continued flourishing of the discipline. This declaration calls upon mathematicians to exercise this responsibility and provides recommendations for individuals, institutions, government, and industry. Although we adopt the perspective of mathematical research, much of what we write applies equally to other aspects of mathematics. This includes work in the broader mathematical sciences, education, mentoring, publishing, funding, science policy, and use of mathematics in the wider world. The Declaration is conceived in solidarity with other research endeavors and creative professions facing similar challenges both within and beyond academia. It complements other calls for action such as the Uppsala Code of Ethics for Scientists, the San Francisco Declaration on Research Assessment, the UNESCO Recommendation on Open Science, and the UK Universal Ethical Code for Scientists. The International Mathematical Union Committee on Publishing, the Society for Industrial and Applied Mathematics, and the American Math Society have also produced related material. Okay, so this is great, right? We're going to have some kind of declaration about what the field and people like me should maybe do or think, or how they should think moving forward. So this is really truly like the things that I think about on a day-to-day basis. So mathematical sciences, education, mentoring, publishing, funding, science policy, and maybe even less so the use of mathematics in the wider world. But these are all like the day-to-day of thinking about the job. How am I teaching? What am I teaching? What are pedagogical components of that? What's my research? What problems am I solving? What do I think is an important thing to think about? How do you mentor the next generation of people? In some sense, I am the next generation of people. I didn't say this, but I'm what I would call a permanent postdoc at this point. I've been a postdoc for maybe 7 years since I got my PhD in 2019. Publishing's day-to-day job, funding is an everyday thing, and science policy less so, but you do see sometimes science policy that makes you question your sanity. So what are our values? We base our recommendations on what we take to be characteristic values of mathematical research that we have a joint interest in preserving. Among these are the following. I haven't even gotten into this so far, but I just want to align myself and check, are these things that I would consider to be my own values as well? Okay, so we can read these and then I'll tell you if I actually align with um, these values. One, there are many reasons to pursue mathematical research, ranging from intellectual curiosity to a desire to solve practical and societal problems. Underlying much of mathematics is the activity of proof. Mathematical proofs are regarded as conferring the highest degree of certainty to their conclusions, as well as imparting understanding of uh, why their conclusions are true. These characteristics of proof support the scientific integrity of mathematics. That's generally maybe how I would believe. A lot of my day-to-day thinking is on understanding certain arguments and also getting an understanding of what computations are saying. I do have a high value in proof. It's not the end all be all, is something else that I would say. So I think that you can have very interesting ideas that may not confer proof of maybe something that you were trying to prove in the first place. So it doesn't happen so often that you get 99% of the way and you can't finish something, and still 99% of the way is actually interesting. But I think the line of thought can be valuable still, or at least showcase like the difficulties that you run up against when you attack a certain problem. Okay, so 2, results are attributable to the specific authors who take credit for their discovery and assume responsibility for their correctness. These principles ground the merit-based standards to which we aspire in mathematical research. Unfortunately, that's true. Like 99% of the stress in my life sometimes has come from whether or not I believe even something that I've said. And I think that is because I have attached my name to it. So, for example, like there are websites online, right, where you can go and you can ask questions or post comments. And I think having your name attached to an account where you're asking questions or posting comments, it does add a sense of responsibility that can be honestly quite deterring in some ways. So, sometimes you don't want to look stupid in front of a bunch of people that you feel are smarter than you, so you don't want to ask this question that has your name attached to it. That's something that is negative a lot of times. But they do ground the merit-based standards to which we aspire in mathematical research. And I guess aspire here is just saying that, some people's names carry more weight than others, and we aspire for that not to be the case, but frequently maybe it happens. So mathematical arguments are regarded as transparent and subject to independent verification. They may be extremely long or difficult, but in principle, no proprietary knowledge or equipment should be required to understand them. Yeah, that's probably not so true, right? I mean, I don't know how true or false it is, but like historically, mathematics has been a field where only wealthy people contribute, and that's just because it's not something that really produces necessarily like a direct return on the investment of time spent doing mathematics. I think that you could say it's great that given the access to knowledge to people with less wealth, then they should be able to, in principle, get the same amount of benefit learning the mathematics and be able to do the same level of mathematics. But definitely, even in my own life, it's been very clear that, like, I mean, I'm sure that anyone can attest to this, so I don't think this is very controversial. But the amount of time that you spend working on something is directly proportional to how much you can produce, and how much you produce is oftentimes weighed quite highly in the field of academic mathematics. And if you're wealthy, or if you come from a privileged background, or if, for example, like in my own case, I lived quite a number of years with my parents, and that gave me, I think, a time advantage in how much time I could spend doing research. So when I don't have to worry about, for example, procuring groceries or cooking dinner, I can spend more time doing mathematics. Similarly, having a family, having children, this is something that takes away your time from doing research, and you have to really, separate whether or not like a good thing that it's valued so highly. Hi, Chacha. That we focus on productivity in this way. I don't think that this has been a permanent trend in academia, but definitely it's been a trend of the last like 50 years of business oriented academia. Sorry. Okay. And mathematicians share a concern for proper evaluation of mathematical work relative to shared standards of depth, difficulty, and significance. Okay, I think this is what I'd say here. I think that's a statement about refereeing. They share a concern about the proper evaluation of mathematical work. I think that means something along the lines of like, you maybe did a bunch of mathematical research. How is that research being evaluated? In the typical process of the day-to-day, what you would do is you'd submit it to a journal, and then ideally an editor would, through a bunch of channels, get some opinion on the paper that you just submitted or the work that you did, and then there would be a independent review from someone that, okay, a lot of times ends up being maybe someone that you even know or someone directly in your field. And yeah, so the evaluation there is just probably trying to get some amount of proportional evaluation for whatever the amount of work that you did was. And I think that there is a genuine concern here. I think that standards in refereeing are field dependent, but in my experience, total. Like I don't want to say anything negative about the people that have directly refereed my papers. I think one thing is that like I could say something and it could be taken by someone that maybe had uh, uh, an experience refereeing my paper that I would have considered positive, and then they would all of a sudden think that I'm speaking negatively of them. But I've had negative experiences with refereeing of my papers. So like comments that are negative, or at least I perceive them as negative or very critical. The amount of time that it takes to get a paper refereed sometimes. This could be field dependent, right? So like me and a collaborator have had a paper in review for 30 months at this point, so 2.5 years. And that's like kind of unacceptable in a lot of ways. So, if you have a job where getting the next job is dependent on kind of getting a publication every year, or 2 a year, or 3 a year, or whatever, then when it takes 2.5 years to get a publication evaluated, and this is like before the effects of an increased number of submissions, then this is problematic. So I think this is what the concern is. And then 5, mathematics produces not only a body of results, but also understanding, clarity, and judgment among the communities of mathematicians who have shaped them. Mathematics produces not only a body of results, but also understanding, clarity, and judgment among the communities of mathematicians who have shaped them, often in the context of their own autonomously guided research. This expert knowledge is essential both to effectively use mathematics and to continue to articulate new and significant research questions. A key source of strength of the discipline has long been the autonomous shaping of the direction of research and the methods used to pursue it. Yeah, that's kind of true, and I don't know. Is this a core value? It is a core value that, yeah. I mean, this is probably the most important thing about research, right? It's not that you're adding to the body of results, but you're contributing to the understanding of a field. And people nowadays, I think, do weigh oftentimes more highly a paper or some kind of result that is much more clarifying or adds quite a bit of clarity to the field than they would if it's just a really hard result. Oftentimes those two are correlated, but they don't need to be. Okay, so having expert knowledge in the field is essential. I can't imagine a field where that wouldn't be considered the case. Like, if you have a bunch of programmers and none of them has expert knowledge in programming, that sounds just insanely detrimental to the field. It's like the same as having a bunch of doctors, but none of them have expert knowledge in medicine. That just sounds stupid, right? Yeah, and probably no one wants that either. So, okay, these characteristics of mathematics as a subject matter are also compatible with understanding mathematics as a human practice and its place in the world as mathematicians, and also as inhabitants of a shared world. We have a duty to care for other people and our environment. That's true. This seems like a human statement, just like as humans, we inhabit a shared world. We have a duty to care for other people in our environment. That's generally how I feel a lot of mathematicians feel. That's probably true, although independent of mathematics. So those are the values, or at least, aspects of being a mathematician. What are the potential threats that we see from AI? Recent developments in artificial intelligence threaten each of these values, often in ways that disproportionately affect students and early career mathematicians, and hence the long-term future of the discipline. This is one of those times where I think, am I still an early career mathematician? I've been a postdoc for 7 years. I'm on my 4th postdoc. I've traveled 4 times to 4 different universities in the last 7 years, and that's not including traveling out of my PhD program. I had to write down recently where I've moved to over the course of, let's say, the last decade, and it was like I've moved 14 times in the last decade, and okay, it's less than ideal, is what I would say. So 1, current automated techniques can produce plausible but unreliable or even incorrect arguments which are difficult to distinguish from correct mathematical proofs. This applies not only to informal arguments, but also to formalizations, where the difficulty lies in the translation between computer encoded and human presentations of concepts. These fast-moving developments put our present system of review under increasing pressure, jeopardizing our ability to implement traditional standards for correctness, transparency, and the independent verifiability of proof. That's just true. Technologies. Sorry, I'm gonna drink some water. Okay, technologies that draw extensively on the published mathematical commons undermine the traditional system of attribution. I've personally experienced this already. I mean, both of these things I could say I've personally experienced, but I think probably almost everyone that's tried using these things has had some experience of this. Well, I'll say more in a second. Models trained on published works frequently return outputs that do not properly cite the human works they synthesize. Many current models are also built on data obtained by systematically exploiting licenses and access arrangements that were not made with artificial intelligence in mind, or indeed by simply just violating copyright protections. Okay. Definitely, I've actually experienced, like, okay, I'm stuck on something. I have to prove this statement. Can AI do this? And the answer was yes. AI could do it. And when you see the proof, you think something like, there is a group of people in this world that know what I was trying to prove and how to prove it, and this is how they would prove it. Or, historically, some group of people knew how to do this process, and I just at the present moment didn't. And then that's it. You have no idea where exactly in a paper this would have been proven, or like what techniques someone would have used to get there. It's impressive a lot of times, and useful too. Like, I don't think it's necessarily a bad thing that it can produce such a result, but oftentimes you would also like some follow-up of like, has this come from somewhere before, or is this like truly a connection that was made with the neural network or the large language model? I don't. And it's not so clear just from the results that you get from these models. So the other aspect to this, right, is many current models are built on data obtained by systematically exploiting licenses and access arrangements, or just violating copyright. And that's something that is interesting. I've definitely thought about this before too, right? I have something like let's say 18 papers, and not all of them are on the archive. Some of them are on my personal website. and you think something like, if they're on the archive, should I just assume that they've been scraped, that their data is in a large language model, and these papers are that were being produced free, or at least without any benefit to me in the sense of direct compensation. Now they're actually being used as like a way to increase the capability of these models. The other aspect is like I had a book on my website. It's like 120 pages, and it says like it's free to use and modify for everyone. But this was made without the understanding that like, yeah, I mean it'll become a set of training data for one of these large language models. I don't know exactly how I would consider the effects of that on my decision. I definitely think something like nowadays, because the primary concern is funding and surviving with the funding that you can get or have. This is something that like if it was valuable, then I wouldn't have given it out for free, right? And so it's just a question of do these companies see it as valuable, and if so, then I probably wouldn't have given it out away for free. That's the way that I think a lot of people are thinking right now. 3 technologies which affect the way in which mathematics is practiced may disturb the current system of incentives. The use of artificial intelligence and thus also, sorry, hold on a second. I don't know if you can see my cat. He's like in this chair just going crazy right now. Okay, technologies which affect the way in which mathematics is practiced may disturb the current system of incentives. Technologies which affect the way in which mathematics is practiced may disturb the current system of incentives. Okay, yes. Right. AI might change the way that we do math, and that also changes the way that we incentivize kind of our work. The use of artificial intelligence, and thus also the sort of problems which it can address, may become incentivized for its own sake. So they're worried about us solving problems to make artificial intelligence better, potentially, or solving problems which artificial intelligence is really good at, because because artificial intelligence is really good at it. So why not do more of that? Right. Currently, we're probably incentivized, I said this before, but for producing lots of work. That's definitely something that you get incentivized for. And I'm actually not convinced that that's like a bad thing. So some people would probably say that high quality work should be more incentivized than high quantity of work. I don't necessarily think that the two are the same, but I definitely think that there's a correlation between the two. If you produce a high quantity of work, oftentimes you can also produce good quality work. There are extremes where this is maybe not true, but definitely I would say that like if you're a mathematician and you're worried about just producing high quality work and you write something like a paper every 3 years, you should better ensure that it's a really fucking good paper, or else I probably think that you're maybe underachieving in some way. The use of artificial intelligence, and thus also the sort of problems which it can address, may become incentivized for its own sake, disrupting our mechanisms for hiring, funding, and recognition. This disadvantages researchers who do not have access to the technologies or decision making related to them, or who are unwilling to use technologies controlled by organizations whose values they do not share. I think that there are a few aspects of just this one point, which are like the primary things that people would say that they're concerned about. So there's some amount of concern about how will hiring look for people like myself. So if there's 10 people, 10 candidates that are going to be hired in this upcoming academic season, hopefully, first of all, there is still a competitive market where there are jobs to be had. That's maybe something that people would worry about, but what they would really be worried about is like, if they're not using AI, then are they going to be at a disadvantage to someone that is using AI? So do you kind of have to use it to produce just a lot of results so that you actually look like you have a competitive application? I think already there are a lot of people that would probably agree with the statement that it's difficult, if not impossible, to evaluate another person and their research um, just from looking at their publications, or even if you go and browse through their publications. Um, how do you gauge, for example, your opinion of the impact of their work from reading even just like as much as you possibly can of each individual applicant for a position? So typically in academia, there's maybe something like at an R1 university, let's say in between the numbers that I hear are like 300 to 600 people applying, but usually it comes down to even like a few dozen that are really competitive. And then it's like, what specifically is the university trying to hire for? Do they have a specific field in mind that they want to hire? How prestigious do they feel like they are? So is there a standard or level that they just won't drop below? So if you don't have papers in X journal, then they just won't consider you. And there are a bunch of universities that I'll say completely operate this way, or have the phrase something like, if you don't have a paper in Inventiones Annals or Duke, then you're not going to get the jobs, or maybe just replace Duke with JAMS, some other journal. Um, Applying for funding, you can just apply that same argument straight to funding if you apply for an NSF grant, which is, let's say, again, a hyper-competitive application where, you hear it takes maybe 5 applications, so 5 years of applying to get a grant. Then are you going to look less competitive if you don't use AI to write your grant proposal, or write some part of the grant proposal, or help you come up with ideas? And then recognition, maybe AI is taking away some of the recognition that you feel like you would have if you had some result. I don't know. I'm not going to think about that too much, but I definitely feel like this is maybe a place where I have a lot of gripes with the system just in general. So, using artificial intelligence in a lot of these ways, I actually don't necessarily have a ton of problems with. Like, if you can use artificial intelligence to prove a lot of results that you would have considered already to be good, then I kind of think that is just going to be the direction that you should go with it. No one's ever going to look down on you for doing, more good work. There is some kind of concern that in this same direction, like, will you start doing the work that the AI is really good at? So you do lose maybe some amount of that autonomy if you're just trying to solve problems that are all right at the cusp of what AI can and can't do. Obviously, this disadvantages researchers that don't have access to the technology in all the ways stated before. Maybe they can't write their grant proposals, or strong grant proposals. Their applications to jobs don't look as competitive. This is an interesting one to me because in a lot of ways, the natural sciences, it seems like, they've all moved in this direction, right? You don't see chemists that are still working from their house without any equipment at all. Now, if you're a competitive researcher in chemistry, I imagine you have some, multi-million-dollar lab where the equipment is just a tremendous cost, and like the main thing that you actually get funding for. And I could see AI kind of pushing mathematics in the same direction, where having access to compute is like the same thing as having access to some really fancy new equipment. So instead of writing grants saying like, oh, I'm going to prove these theorems, you're going to write grants saying like, okay, so instead of writing grants that say, I'm going to prove these theorems, please pay me to do that, you'll write something like, I'm going to prove these theorems, I really just need the compute. So please give me money so that I can buy the compute. This is one of those areas where I feel like having applications that are more geared towards local systems is probably ideal. So if somehow out of this declaration there's like an incentive to like really push for the accessibility of like local models, or at least giving mathematicians tools, that they can train custom models as a community, and then maybe have access to some kind of open thing where it's just really good at math, or maybe there will be some kind of collaboration between certain companies that make AI models that are specialized in certain fields, and then you have like an algebra AI model, and it fits hopefully locally on some machine that you can buy with a grant. So maybe out of the budget of a normal desktop machine, but like if you get a $50,000 grant, now you have like a couple of GPUs on your desk, and then there are like some companies that sell you a model that's good at some algebra, and you can maybe fine tune it with your own papers. Maybe that's not out of the question for what you could see in the future, and that's something that I don't know if I would really think is a bad thing. I get the appeal of wanting to, keep the field accessible, but also it's probably not worth um, halting progress in other areas for that. I don't know, maybe tough moral question, but I'm kind of for the use of AI in a lot of these aspects, honestly. Okay, so 4, proper evaluation is endangered if results are communicated through informal channels such as press release or blog posts, often without any research paper or other disclosure of information necessary for scientific evaluation. I think this is just total bullshit. I mean, so I imagine this is just a direct complaint that some of these AI companies are releasing, like, a blog post, they solved some 80-year-old Erdish problem. But like, no one cares that it happened on a blog post, right? Except for people that have some amount of like credibility to lose, that they can't see. If people are posting these really great results just on their blog, then my really good papers in this prestigious journal are going to look like they're just because I'm a prestigious person, and not necessarily because the results are really good. I could maybe see that as an argument, but yeah, like no one I've ever known has cared about where the results come from, and basically everyone in the field already is publishing just, I mean, yeah, you put a paper straight to the archive, and if it's like an interesting paper, then it's interesting, and you read it there, and then I think for the most part, except an evaluation on like, are you going to get hired, or should we give you this funding? Does anyone ever care about what the journal you publish the paper in is? So I think if you communicate results through informal channels and they're good results, then people will think that they're good results, so long as they're understandable and are important in the local sense of people view them as important. This practice seeks publicity for new results on market timelines before the accepted process of community evaluation in mathematics can take place. This kind of seems like more griping about like OpenAI releases blog posts saying they proved some fancy thing. It's second quarter, and now I can't even imagine. I don't know. They're gonna IPO soon, right? So maybe this is like they're trying to really hype up their stock price, and this is kind of, people are complaining about that. Okay, this is partly actually why I'm making this video too. Is just like the number of things that I've seen in the media that say something about mathematicians, or like the state of mathematics, or some interview about like where mathematics is going, how good are these local AI model, or how not local, how good are these AI models at mathematics? I mean, sometimes you think something like, oh God, there are a bunch of people that are making opinions, and you feel like it's not something that you'd actually hear from anyone in what you would consider like your mathematical community. So do I think that it's problematic that these people put out these results on a market timeline and didn't allow for the proper review process of community evaluation to take place. I kind of, I mean, I know for a fact that at least for this last unit distance conjecture, right, they put out a blog post, they contacted a bunch of mathematicians, said, hey, can you look at this? And then they put a preprint on the archive. Like, that is, in my mind, pretty much sufficient. Those mathematicians, like Will Sawin and Daniel Litt, I feel like you know that they're going to read the paper, or at least they're not going to put their name on this thing, making comments on it, saying that they had read the paper if they didn't. So, like, in a lot of ways, that's even better than a journal posting or journal article. I don't care if the result comes out in a journal. Does anyone care if the result comes out in a journal? Maybe people that work on that field. Let me reevaluate my own thing. If one of these model companies, Google, Anthropic, OpenAI, prove the Hodge conjecture, which is something that I would say like I would actually care about, and then they just put that out as a blog post, or like they disprove the Hodge conjecture, they put that out as a blog post. I still wouldn't give a shit. I don't know. Maybe that's just maybe that's my own preference. Like, great. In some ways, you know, a huge problem doesn't go to a great journal. That's like even better than if they prove this thing and then put it in a big journal and it took a fucking year and a half. Whatever. Okay. In many cases, this leads to simplifications in reporting, such as overemphasizing the significance of automated tools and undervaluing the prior human contributions which have made these tools possible. I think this is true. I think that's fully true. A lot of times when you see now interviews, these things that I'm kind of actively bitching about, and there's like talk about like what is the future for mathematics. I mean, like, I just listened to one today, and I get the sense that like yeah, the general public really doesn't know like anything about the amount of effort that's gone into developing the field of mathematics. And if you think about just the tools that went into, for example, the unit distance conjecture, the number theory is like, yeah, I mean, pretty involved, and the amount of algebra that's used in the proof or the disproof of the unit distance conjecture, it's definitely a very well developed area that you know, experts say there was never a direct approach in this direction, but like all of those tools are like so well exposed. You just have to imagine that this is a problem that would have been really well posed for an AI. In many cases, this leads to simplifications in reporting, such as overemphasizing the significance of automated tools and undervaluing the prior human contributions which have made those tools possible. Such oversimplification risks influencing public opinion in a way that not only damages perceptions of mathematics, but also misleadingly uses specific mathematical tasks as metrics for the general reasoning capacities of commercial products. Okay, so I don't know. I feel like there's two things here. One is just it's easy, I think, to complain about the standard of reporting on mathematics, or really in any field in particular. If you think about just the media that you consume on a day-to-day, or at least if I think about the media that I consume on a day-to-day, the headlines are always like, some study did this thing, and you know that it's like the most bullshit thing you've ever seen in your entire life, where like you know, it says like new cancer cure found in mice. It does like Alzheimer's reduction. Should see human trials in, you know, a year, and you're like yeah, I don't know, probably not. The same happens in the mathematics community, right? But in a lot of ways, this is like a problem of the communication standards that mathematicians have just in general. Like, we do want to be understood, and it's very hard to explain a lot of technical concepts without, you know, losing a lot of the meaning. So there's like problems with the, let's say, American media, where they're definitely not going to report on mathematics. No one's going to care. and so they want to make these tools sound impressive. They're going to say that it's really good at mathematics. That's just what's going to happen. Easy to complain about, though. The other one is that this will hurt the public opinion of mathematics. That, I think, is actually directly happening. Like, I would be surprised if undergraduate students, for example, were less inclined to pick mathematics as a discipline to pursue as a major. Same with computer science, because of the perception that, like, mathematics, quote unquote, could be solved by AI. The same with the way that coding could be solved, and both of those two things are just probably going to be explicitly false. Like, knowing how a computer works and how code is produced, and being able to understand how code works in different languages, like this is probably still going to be an important thing to know. Like the same how students are taught assembly language, but no one directly codes in assembly. So, like, maybe you will be taught Python, but you won't ever directly code in Python. Maybe a lot of times you'll just set up the structure of kind of how you want your program to run, and then it will write the program. In mathematics, there's definitely going to be places where you can do mathematics. I mean, even if the machines took over, right? There's just not enough machine. You're still going to have, I think, places where you can contribute just by working on a specific area. You could say, like, okay, and I'm going to just say, I don't think the machines are going to take over. I think that, working in tandem with the machine, that's probably what everyone expects is going to happen. Where, yeah, I probably won't spend all of my time the same way I have in the past doing research. But there's a lot of things that I've done in the past that I just shouldn't have done anyways, even with computational tools that were available before having AI around. And if anything, I would say that, like, having the ability to move from, not having these tools to suddenly using them, like using computer algebra systems, this is a great thing that AI could actually provide for you. You don't have to necessarily do all the coding yourself. So if you had a project and it would have taken, a week to do by hand, you could probably get that done in like a couple hours with an AI system right now, which is great. If I wanted to give an example for the mathematicians on something that I'm actually talking about, there was a while ago where, when I was a graduate student, I had a notebook, and one summer I was trying to do these computations where I wanted to write out something like, okay, they were the K-theoretic Chern classes in exterior powers of a vector bundle. So I was trying to do something like, if you think about they're called gamma operations of lambda operations of some class in K-theory. And I was trying to expand these out in terms of just the K-theoretic Chern classes. So it's some, you've got some. I was trying to do this on for the K-theory of a Grassmannian. You have some polynomials. You're trying to write them as elementary symmetric polynomials at the end of the day. And this is like something that a computer could do, and I should have just used a computer, but I didn't know how to code at the time. So I spent like a couple weeks just writing out a bunch of examples, trying to see if I could find a pattern. And I have like a whole notebook, like 90 pages or something, where like, one of these computations takes like 20 to 30 pages. And I never found a pattern. And now if I wanted to, I could go back and I could just ask an AI system, like here's the rule, make this ring, and then do this computation, and then change it into some, elementary symmetric polynomials, and it would do that for me. And that's something that, like, I don't actually need to know any coding now in order to do that. I mean, maybe that's not totally true. Knowing some amount of coding is still useful, but so public opinion on the perception of mathematics, it is negative, and in some ways I think that's just unjustified. Like a lot of things, there's a huge amount of concentration of media that influences large groups of people right now. I think even lately I've seen that like I'm old enough and the media that I look at is specialized enough that there are a number of topics where I just disagree with the majority of people. So that's part of the reason why I wanted to make this video, right? 5, these developments put the autonomy of mathematics under threat. Yeah, maybe. The increasing involvement of technology companies in mathematical research raises the risk that research questions may come to be prioritized because of their amenability to automated mathematics, rather than expert judgment of their deeper significance. That is something that I was saying earlier, which is just, which I thought they were also bringing up earlier, which is that like you kind of are incentivized to, focus on these questions that are doable by machine rather than something that you would actually be interested in. There's kind of a flip side to this too, which is like I've spent a lot of time thinking about problems which are really bordering like is this an even possible problem? And there are mathematicians out there that I can think of that have had these rules at least in their head, and sometimes even explicitly stated in other ways, where there's like one group of problems that follows some kind of approach, and then another group of problems which follows generally like unique approaches each time. So maybe there's a problem that, for example, is like very geometric, where if you wanted to construct a counterexample, then you kind of look at the generic thing, the most generic thing, and then there's some way to go about getting a counterexample. Versus, okay, something that's very arithmetic, like if you want to do this thing, you have to actually prove like there exists some kind of rational point on some variety or something like this. Like these are different problems, and generally speaking, one of them is much harder than the other. So it could be very difficult to like ever prove that there exists some solution to some system of polynomial equations. Not only could it be difficult, it could just be like full stop. There's no way to do that, at least by some routine approach. So every time you do it, it's like a totally new idea that had to go into to actually getting that result. And I've heard explicitly mathematicians say, or like one of those should be weighted higher than the other one, and I would maybe agree. So focusing on mathematics that can be automated and that's good approach by a machine. There's some caveats to be had. There are problems that like sometimes you find they reduce to this harder version. Like eventually you find out like you were trying to solve blank really difficult problem, and then you have a choice maybe of deciding, do you want to spend more time working on that problem, or do you want to shift your attention to something that you can actually maybe accomplish in a reasonable time frame for the productivity that you want to meet. I don't think that it is interesting. Like there are problems that I've worked on also, right, for like let's say like 6 years that just never got solved. Like I mean, not even never got solved, but like there's still seemingly no direct route in order to resolve like at least one of these problems that I thought about for like 6 years. And some amount of work that I did was just like trying over and over some different approaches to solving one specific question or resolving one specific question. And like, okay, I think that knowing, that it's a difficult problem for an AI to solve, like I already knew it was a difficult problem to solve, but like knowing that it's a difficult problem for an AI to solve, it's just like a statement that computationally it's a difficult problem. There has been in my head at least, a change. So in the last couple of years, I got really into programming and computers and actually thinking about like algorithmic solutions to problems. And there has been kind of a neat, I think, distinction on how you solve problems. So mathematicians probably don't always outline it as such, but sometimes people come up with like some idea and they can solve some problem by some algorithm. It's like they want to give an example, and to produce an example, they follow just this specific routine or some specific algorithm. I think that coming up with these is like, okay, this was something that a computer could do really well, right? Because a computer can solve, or at least it could follow some algorithm really well. I don't necessarily think that that's a bad thing. It just is like a declarative thing. Like the computer is good at solving this type of problem. That's something that we can do. That's interesting. That's still interesting. It's maybe just not the only thing that you want to come out. But also you don't want to have a bunch of people spend like, their entire life thinking about these problems that um, are never going to get solved, or like they're going to take just way too long to solve. Yeah, I don't know what the best I don't know what my like full statement is here, other than having a strict dependence on like choosing your problem because the AI is good at it. That sounds bad. But also, do I even think that AI is going to get good enough where there's like some problems that are obviously solvable by AI? Maybe we'll just have a better understanding in the future as mathematicians of like which problems the AI is good at, which problems the AI is bad at, and then we'll actually have some amount of weight to how much like new stuff was done in a given paper. I think that could totally happen. Where for example, yeah, you have some report papers maybe smaller, the proofs are just stated roughly, with the theorems being the main important thing, and maybe a bunch of computations and like the data, and maybe some of the facts are like left out, and you kind of know what was the new work that was done, and then the old work, the work that was done by AI um, in this paper, is something that's kind of inherently clear. Okay, so indeed, broader understanding of the field may be permanently lost in the process of automation. That could be true. With university budgets under pressure, this reshaping also changes professional incentives in a manner which encourages the collaboration of researchers with technology companies on asymmetric terms. That's maybe true. Maybe people feel compelled to try to get some assistance from technology companies, or like apply for grants from technology companies, or just like, I mean, universities or businesses just like any other, and you can see in the hiring applications, at least like what people are putting applications out for, that sometimes there are fancy buzzwords like quantum computing, AI. There was for a while data science as a field that was advertised for, and definitely it does feel like having kind of some amount of those things on your application would provide a benefit. So maybe there are some people that are collaborating with companies on asymmetric terms. If left unchecked, these trends go beyond threatening researchers' autonomy, affecting the scope and depth of mathematical research itself. I guess we'll have to see how good AI really becomes at automated research. It could be true that like the research that does get automated, it just is seen as totally worthless, or at least less valuable than some new insight. And I think there are these people out there that would probably say something like, all research is just going to be automated. But I think that this is just not going to be true. There was a period where I was on the fence of thinking, um, if research can be automated, then why can some research not be automated? Or like why would there be a process that could not be just given to the AI? And now I'm not even asking why. I just think it's maybe not. I don't think it's going to be true. Yeah, I think that not everything is going to be able to be tackled by AI. Okay, so all of these challenges arise at a moment when the consequence of large-scale investment in artificial intelligences are being widely discussed in regard to warfare, mass surveillance, political disruption, and environmental damage. That was definitely a big topic in the last few months. toned down a little bit, maybe as of June. These raise grave ethical concerns. By failing to act, we run the risk of becoming complicit in the support of technologies which threaten much more than the practice of mathematics. We thus feel that there is an urgent need for considered response from the mathematical community. The following constitute brief descriptions of actionable recommendations. We encourage professional organizations to endorse this declaration and to add provisions according to their own values, priorities, and governance. Okay, so far I would say that the declaration is good, and it's definitely needed for people to have some amount of action taken on some things. I think that there are some things that I maybe don't think will go in the way that the declaration wants so far. And then there are some that I really hope it does. So I think I've already pointed out that probably it's just not going to be as accessible as a field for people that have access to AI tools and people that don't have access to AI tools. But I don't think that's even a new thing. I think that that's like the people that do math have always historically been wealthy, and that is going to be true in the future as well. Okay. I think that there's some amount of concern regarding the way that companies are treating researchers and research work. And I think that it's not open, it's very opaque. And that is something that I really do hope people take action against. So if companies find value in the work that's put up on the archive, if they find that it actually directly improves the capabilities of these models, and that's something that they want to sell, like capable models, then I hope researchers somehow are compensated for their work. Those are like two examples of one going in the way of the declaration and one not going in the way of the declaration. Just in reverse order. So what are some recommendations for individual mathematicians? I think this is where I'm like, maybe there's a couple of spicy comments. So disclose tool use. Transparently disclose the use of automated tools, including large language models, machine learning systems, proof assistants, and other mathematical software. Include a tool and computation resource disclosure section in your papers. Many journals, publishers, and professional organizations have already developed guidelines for this, and though the precise form of such a section will necessarily evolve, we encourage authors to live up to the spirit reflected in the UNESCO recommendation on open science and the FAIR principles. When acting as a reviewer, abide by publisher guidelines. If the use of artificial intelligence is allowed, be transparent about how you used it and take responsibility for any significant recommendations you make. I genuinely feel like I would be so happy if the publishing world just like went away. If everyone just put something up on the archive and that's where it ended, that would be infinitely worse and better at the same time. I was just thinking it would be infinitely better. I wouldn't have to ever worry about sending my journal to some, paid for publisher that's going to charge a university $16,000 a month just so you get access to those journal articles, which you yourself have to pay $40 for if you want to get past like 5 copies of your own downloadable PDF article. Not to mention the process of like, I don't know, meeting the style guides of each individual journal and having to download these tech files, make sure everything looks nice. Why am I doing the editorial work on this file that, I'm not getting paid for? I'll just say it, to make it into a state that goes onto the publisher website. I feel like talking to people in more literature focused field, like talking to MFAs of like creative writing people. Sometimes it's crazy that you can know someone that sends out their work to maybe multiple journals at the same time, and then once it gets accepted, they get paid for their work. That is something that just like does not happen in mathematics. And maybe there would be some shift if there's a lot of submissions. Maybe you do have to send out your journal multiple times and just hope someone will read it. Who knows? The bad side of like if journal publishing just completely went away is that obviously recommendations would be like you either have to work directly on what someone finds interesting and then you could maybe work with that person, or you just get recommended by someone fancy. And so I think in that case where like journals just completely went away, the main focus that would actually like I don't know, improve your career or actually get you a job would just be networking and prestige. And okay, although I don't think networking is like the worst thing, I do think there's a lot of that which is out of your hands, where you're born, for example, where you go to school. And then prestige, I genuinely also just would say that I hate the concept of. So maybe although it would be easier to just not worry about journals at all and not deal with all the bullshit that they entail or the ethical concerns with publishing, having to publish, um, maybe it's not a better system. It's hard to say. Am I going to be doing this, including a tool and computational resource disclosure? I think that if I use computational resources, I generally feel like I would want to disclose that, mostly as some advertisement for the computational tools. Like if I used Oscar, open source computer algebra research system, I would disclose that just because I also want people to know more about it. And the more people that know about it, the more people that can contribute to this open source system, which I think is good and beneficial for the community. If I used a proof assistant, then I think I would also say that if I just had the facts that like all of these theorems are true according to this proof assistant, here's the theorem statement. Hopefully you read it and you think that really is the theorem statement. Then I would use that. Machine learning systems I don't generally use. I don't have anything to do machine learning on. If I did, that would be like the whole topic of the paper probably. And large language models, that's the one where I'm like, yeah, maybe I'm not gonna do that. Maybe I will, maybe I won't. Depends on, I guess, how I used the AI model. I use AI models for like, try to get your usage out of them on the daily usage limits. If you use something like go back and check all these commas, of course I'm not going to report that. If I use it and I'm like, like, should we go down this way? Here's like a proof sketch. And then it says like, no, there's a blatant error in this. And then I agree there's a blatant error in it. Like, I'm also not going to report that. I think that the main thing here is to actually take credit with what you're doing and actually verify that things are true. If you get something from the AI model and it's beyond your capability and you don't have the ability to actually verify it, then I guess you could say you used this model and it proved this statement. That's like a use at your own risk statement for a lot of people, and that's like an honest thing to do. I don't know if I would feel comfortable personally with putting anything like that in a paper, I guess. If I put it in a paper, I really want to have some kind of ownership where like I do believe that this is true. And okay, I probably would just try to verify it. I don't know if we'll ever get to the point in my lifetime where I'm gonna be putting things in paper where I'm like, this part it was all Gemini or this part was all Claude. Like, and I didn't at any point try to verify or understand it. Like if I think it's a really important problem, like I also want to get the understanding. I will go through and read it. But yeah, people could in that situation there, right there, I could actually see people saying like maybe I'm underestimating how fast things will change. But I'm not so sure. I don't know. Okay, support the needs of reviewing. The use of artificial intelligence in preparing papers can introduce material that makes reviewing more demanding. Make it easier for your peers to review your work by disclosing tool use, giving precise and complete references to previous results, and providing formal proofs where feasible and appropriate. Yeah, probably just keep it honest. If you understand or think you do, have a good understanding. This is like, as a graduate student, probably a lot of your, I mean, okay, as an undergraduate, probably a lot of your transition is just figuring out like what does it mean to have a good understanding. And as a graduate student, there's some like loosening of that a little bit, where there's like so much stuff that you have to learn that like there's some stuff that you have a good understanding of, there's some stuff that you don't really have a good understanding of, and you kind of have to balance the in between of those. So like sometimes you do use statements that like maybe you don't have a perfect understanding of. Um, but I think that's different than like the AI gave me this statement and I didn't try to read it at all. Like I think that you should have some worldview of like what is true and what is not, and you should really, if you send something to a journal, believe that it is true. Like that's the most important thing to me, is that you believe that it is true. I'm not just gonna be wasting my time trying to read something, right? Make it easier for your peers to review your work by disclosing clues, precise, complete references. That's just good to do in general. Adhere to principles of open science. The international open science movement aims to make scientific research transparent and accessible to all. As mathematical research becomes more reliant on data and software, adhere to principles of open science. I've never seen the principles before, so let's see what they say. A bit too long for me to look at, but maybe there's like I was hoping that maybe there was like a table of contents that I could just read. Maybe I skipped it, but okay, let's try to make a best interpretation of this. So, the open science movement aims to make scientific research transparent and accessible to all. As mathematical research becomes more reliant on data and software, adhere to principles of open science. I think that in general, the more people that can understand your paper, the more people that can gain something from what you do, the better. So that's probably just something to adhere to. Retain the responsibility for correctness. That's, I think, what I said in number one. So when automated techniques are employed in published mathematical research, the responsibility for the correctness and adequacy of the arguments and results, as well as the completeness and accuracy of citations to relevant prior work, remains exclusive with human authors. I feel like that should be a no-brainer, to be totally honest. Maybe sad that it's not. Affirm the humanity of authorship. Credit and responsibility continue to belong to humans within the mathematical community and should not be given to automated systems. Artificial intelligence may obscure, but does not replace the collective human labor behind a result. This one has two parts, right? Credit and responsibility continue to belong to humans within the mathematical community and should not be given to automated systems. That's maybe not true, I think. Responsibility belongs to the humans. I think that is true. But I think credit could definitely go to an automated system. I don't see why it shouldn't be able to. Like if there's some theorem and the first proof is like by some automated system, I get that, there's a corpus of research and knowledge that goes into giving the background to the automated system, and that's like a huge human accomplishment that we built the system that could maybe piece some things together to prove some result. But like there's maybe some worries that like if you start crediting the automated system, slowly all of the um, citations and the work that people have done is just going to get eaten up by this automated system, and then no one's ever going to get any recognition for anything. But I definitely think that computers will be able to do something completely new, and I think that there's some amount of like credit that you could give to an automated system in that way. Put effort into proper attribution. That's probably a good thing. I don't even feel like I want to read this. So the known limitations of automated tools in properly attributing ideas create a corresponding obligation for proactive effort to find and credit the sources that made a new result possible. Where satisfactory attribution is not possible, state this explicitly in the publication. I don't think that'll ever show up, to be totally honest. I think that this is a problem that AI companies should work on solving. I don't know why it's not solvable, to be totally honest. I do see that like in Gemini prompts, now there are like hyperlinks that will be like they're like kind of a citation, but a lot of times because the AI like it ingests the tokens and then it like produces something. I don't know if it has the same capability to like the tokens go through some like network of neurons, and maybe when it activates like this result here in this neuron cluster, that is somehow related to like this citation with this person's name in this neuron cluster. Like if that's possible, then AI companies should be trying to do that. But I think a lot of people's skepticism is just that AI companies are not incentivized to do that because if people were aware of like how much work they had used, which was copyrighted, and they used it without the consent of the copyright holder, then they would be in trouble. So I think there's like a lot of incentives for them not to have proper attributions. And that's like something that should be directly solved. Like that's something that definitely I think it would be great if that was a solved problem. If people are using material that they shouldn't be, it should be evaluated and judged by peers, as in like that should be something that would be taken to a court. I think this would be good overall, is to have some kind of citation network. Okay, participate in public discourse. This is kind of what I'm doing right now, right? I'm just kidding. So mathematicians have a responsibility to support serious science journalism and to engage in public discourse to explain and contextualize artificial intelligence assisted methods and results. This is particularly important for work within our own subfields where specialized knowledge is required to assess claims about the depth, difficulty, and significance of results. Moreover, we encourage mathematicians to seek opportunities to cooperate with and support other researchers and creative professionals facing similar challenges. I think that's probably good, is to try your best to communicate, results, and then also support other researchers. I think those are good things to try to do. Stay informed about the emerging technologies. As appropriate to your interests in research, stay informed about the capability of computer-aided mathematical tools. Such understanding is important for informing how our discipline adapts to new technologies and for participating in governance and public disclosure. I think this one is interesting because this statement is like very clear that there's a good amount of pure mathematicians that, even though computational tools have come around already that could definitely aid them in their work, they've just not used them. Like just decided, like I won't use a calculator. I'll just stop using numbers, or like I just won't think about these problems of I don't know, finding points on elliptic curves over certain fields because like a computer can do that better than I can in certain areas, and I just don't want to think about that kind of thing. I think that kind of is already self-selecting, and so like it is interesting that as a point here, just like as appropriate to your interests and research. There's probably also some component of that too, right? Which is like AI is not going to be equally trained on every research field or area, and so there's going to be some fields that are just more well developed in the AI space than other ones. Okay, welcome new contributors. The growing intersection of artificial intelligence and mathematics continues to attract researchers from other disciplines. We welcome this broadening of our community and the range of skills and perspectives these contributors bring. We encourage the mathematical community to actively engage with the broader community, to make our standards and practices explicit and accessible, and to create pathways for meaningful participation. In turn, we ask those entering our field to approach it with respect for our values while also helping us to adapt and develop them. Okay, that doesn't seem like really kind of any statement. So there's just some mingling probably of computer science people and what maybe people would consider as more standard mathematicians. Consider carefully which tools to use. Um, I mean, I don't know. Yeah. Okay. Consider carefully which tools to use. Some automated tools and their developers will align with the provisions of this declaration, while others will not. Consider this when deciding which tools to use or whether to use them at all. Also consider whether non-proprietary, energy-efficient, or small-scale systems suffice for your task. If not, consider how preservation of the values articulated in this declaration may be worth a delay in obtaining results. Yeah, I kind of wonder if this is like choose Claude and not GPT. um, anyways, evaluate the ethical consequences of your work and take action accordingly. Mathematics has led to technology which greatly improves everyday life for many people. Yet it also has applications in the development of technology for use in warfare, oppression, mass surveillance, and the undermining of democracy. Evaluate the ethical consequences of your research to the best of your abilities, and if necessary, withdraw from harmful work. Only enter into external partnerships with respect which respect the values articulated in this declaration. I think this one is interesting. I guess mostly as a pointer for trajectory. Um, I don't think that this is a surprise for anyone that's been in the math community. Um, I think in the 2022 JMM, I don't know how often it happens, but I remember there being a math without militants protest that was going on, something like that. And I think they were protesting the fact that there's some number of mathematicians that do work also for government agencies. The mathematics has led to technology that can be used in warfare, oppression, mass surveillance, and undermining democracy. It's interesting because it's like unfortunately more relevant today than it was, let's say in 2012. Or at least it felt like it feels like it's more relevant today than it was in 2012. Um, Probably everyone has had some amount of, yeah, I mean, everyone that goes through the lower division math classes, I think, should be kind of taught that there's some amount of um, mathematics in essentially every piece of technology nowadays, whether that's GPS used for your phone and directions on your phone, or whether it's GPS used for like evaluating, yeah, military opposition capabilities. And that is kind of a two-way street. I think telling people explicitly, have ethical, like take a good stance, like try to better humanity, is interesting because maybe it's not so obvious nowadays. Um, yeah, I don't, yeah, I don't know how to read into that one. Recommendations for mathematical organizations and not-for-profit research funders. Build expertise and plan strategically. So before I start reading these, actually, recommendations for the individual is what we just read. And recommendations for mathematical organizations and not-for-profit research funders. I guess how do I want to actually think about this? So for mathematical organizations, let me scroll to the next one, see if there is a next one. Recommendations for policymakers and government and elsewhere. Recommendations for commercial artificial intelligence. So I guess this would be like universities as well as yeah, like I guess the NSF, right? Just and there's, I mean, can I think of too many not for profit? I mean, Renaissance Philanthropy has that's a not for profit. I mean, is it a not for profit? I mean, Renaissance is not a not for profit, but the philanthropy division. I guess I don't know too many not for profit research funders, but definitely mathematical organizations. I imagine that's kind of university based. Okay, so what do we say? Build expertise and plan strategically. Professional organizations should keep abreast of technical developments and be proactive in making informed recommendations to members and to the broader community. They should work together to guide the development of policy within academic publishing, funding bodies, and government. They should also actively prepare to become involved if major mathematical results are claimed using unconventional means. I think this is saying more so that that if I I mean, okay. I kind of think that this is saying that if proofs are starting to come out from automated systems that are substantial in many people's minds, then these organizations should intervene in a way which, okay, it's a mathematical organization and not for profit research funder. I think what it means is intervene in a way to preserve mathematicians. Like, for example, universities coming out and saying, like, we're continuing to hire mathematicians and see them as a vital role in the university system and a vital part of the education of undergraduates. And, like, we're developing ways for them to continue being impactful. Simultaneously, for not for profit research funders, right? That's like continue to pay mathematicians, even though there is maybe a significant shift in the way that people are going to work. That one's kind of, I think that's kind of an interesting last comment mostly. They take the lead on policies for publishing and reviewing. Professional organizations within mathematics should take a leadership role in developing guidelines in regard to the use of automated techniques in publication and in reviewing. These would include, for example, tool and computational resource disclosure, attribution, rules pertaining to authorship, and codes of conduct consistent with the values of mathematics. These would supplement and support guidelines already being developed by publishers and journals. Yeah, I don't know. I think having proper attribution, this is always going to be important, but you can already see it kind of disappearing in some fields like medicine and some of the physical sciences where there are people that can get published with like improperly cited works or just like a bunch of self attributions randomly without meaning. Um, rules pertaining to authorship also, I think that's less so important in mathematics, which at the moment is like a complete shared responsibility for the authorship. I mean, math is interesting in that yeah, a lot of it is already who you know, so you're kind of already going to be speaking just for someone or about someone when it comes to a lot of these things. So can I see there being like someone in mathematics that's like blatantly corrupt? I don't think in the present moment. Um, there's people that maybe others would say are not corrupt but total assholes.
They're still around, but I don't think that they're like being dishonest about their work. I don't know if I could think of anyone that would that would match the kind of prevalence of fraud and in other fields. Yeah. I don't know if the automation is going to be the problem. Is kind of what I want to say. Like if there's a possibility that you could like automate the production of your papers, and then there's like key things that you could insert that would make it actually valuable. Like, is someone really going to complain that you automated the script that builds your PDF? Like, probably not, right? Maintain standards of rigor. I think that's probably good. Protect the rights of authors. Automated mathematics presents new challenges to the rights of authors, and societies should be proactive in the development of sample license agreements to protect these rights. I think that one actually is really important. In particular, material should not be used as training data without consent. Publishing agreements should allow authors to opt out of the use of their work this way. I mean, this is true. I have no idea how you enforce this. I think a huge problem with enforcing this is just like, how are you ever going to prove that they violated your copyright license without having some background detail? I mean, they're already forced. I mean, sorry, they're already opaque in a closed source programming environment. There's nothing that they have to show you about what they do or how they get the model at the end of the day. So unless there's like whistleblowers or some open investigation in which you find exactly all of the training material, then I don't know how that would get to this point other than like discovery in some really big case that would be a class action lawsuit, and then you'd get like 70 cents or something, whatever your 10 years of work amounts to. Um, I don't know. On the other hand, I think that like I think that there could be a good system where uh, there's like an opt-in. Like when you put your paper up on the archive, you can like opt in to give your work to certain um, places to use as training data, and maybe you do get some amount of like credit for that. I mean, if I got like 70 cents every time a company used my archive preprint as training data, and there was like a actual benefactor like archive that paid that out and negotiated with companies and like distributed the process of the data, then that would be actually really useful. I don't think 70 cents is a good metric, but and I don't think journals should be the ones that get to do that. I think that there's some amount of like people want um, quality data, so maybe they wouldn't want everything on the archive. Um, yeah, I wonder how that would work. But I think that there could be some amount of good way to get returns for posting your stuff on the archive or the internet. Insist on appropriate publication outlets. I don't think this is important. Demand that mathematical results continue to be published in peer-reviewed venues such as journals, proceedings, and books. I don't think that's important at all. Informal mechanisms such as press releases or blog posts can provide a valuable supporting role, but they cannot replace peer review or community scrutiny. I think the latter is true. That like peer review and community scrutiny is important, but to some extent, this is what you do when you go and review a paper yourself. Is like make sure that there's some amount of scrutinizing that you do, that you believe these results could be true and valuable, and that you'd be able to use them. Um, and I think having a community that looks over the same thing over a period of time, that's interesting. This is like the same argument that I would say that like if there's like 100 people proving a bunch of stuff and just putting it out on the internet, like I probably just won't look at it, and I just won't care. if I do care about something, then I'll go through the process of reviewing it myself. Um, and on the flip side, I think there's like a double-edged sword here, which is like if it takes me a really long time to get a review, that's like a sign that either I'm not doing a good job at getting the work out there to be reviewed, or it's like not good work that people have direction to build on, or want to build on, or want to get something from. Um, I think in a lot of ways, like the work that people find interesting and useful for their understanding, it will get communicated to people. Like it will make its way to people. It doesn't have to be through a journal. Um, so this is in the organization, huh? This is like universities demanding that you continue to publish your papers in journals, even though it's a huge pain in the ass. No one gets paid for it, and the industry has like the highest margins in any U.S. Business. Support public research laboratories. Support the formation of university-based national or international research laboratories devoted to studying automated mathematics, which are administratively and financially independent from industry. This would be awesome. Awesome, awesome, awesome. This would be like an actual way for there to be an open source model that is competitive on a frontier standard and like actually usable on a local system. Like all of the issues that you could maybe imagine, like, oh, AI costs too much to run. Like if there was open source project or like project that was like publicly funded that could mitigate that, like this would be the only way to get it developed, right? Like AI companies are only going to make something cheaper to run to the extent that like it will benefit them. So, there's probably a lower limit to how much they want to invest into making it cheaper, um, without lowering the price target that it costs consumers. I mean, there's a balance there too, right? Like, I guess there's an optimization problem of like how cheap can you get it before it's not worth it anymore. Um, but I think that this would be a university based national or international lab that was devoted to doing this would be great. It would just be one of those things too where like um people would probably make arguments on like why the government based one or the independent third party one is less useful than the non-independent third party one, and they could maybe be right in this case too. Like, who knows how this would go? I can imagine like you know Google maybe has more reason to have a model to make good pictures and videos than a national based lab would, and so maybe the incentives of what the model was trained on and what it could produce is different between the two. I would be more interested in something like this though. Um, Probably, yeah, yeah. I guess it could get data in the same through the same mechanisms of like purchasing it from those like data harvesting companies that sprung up for the AI boom. I was trying to think like it doesn't have the same access to, for example, like code data. Like who knows if it would be as good as at coding. It doesn't have like all of GitHub to scrape and then remove all the licensing from and then pretend like it was just there, right? Provide frameworks for collaboration. Mathematicians and academic organizations collaborating with industry often face asymmetries in their bargaining positions as well as in access to professional support, such as legal resources or advice on intellectual property. Support researchers in such collaborations by providing access to legal representation and by facilitating the development codes of professional practice. Development of codes of professional practice. It's kind of an interesting one that I don't run into, or at least haven't. So I think I'll just move on. But it was interesting that it's mostly about like, yeah, the legal asymmetries here. Mathematicians are a really open group of people. Like if a company approached them and they were like, "Oh, we wanted to, use our model to attack your research field and like the problems that you care about." I kind of imagine they would be like, "Oh, that sounds interesting." Like without pay. Even though there's like also a group of sharks in academia that are like you know switching fields currently so that they can get the $400,000 paycheck at the end of the day, if it's limited at that. Um, Align funding with values. Alignment with the values of this declaration should be taken into account in the evaluation of funding projects which involve collaboration between academic and industry partners. Okay. Recommendations for policymakers in government and elsewhere. Okay. You got to keep your non-cynical hat on. I don't even think cynical is the right word in this case, but you know that the government is a huge entity, and at any given time, some proportion of the people agree with your opinions. And key values that you have, a large number of government employees also share. So protect the rights of authors, strengthen legal protections for authors in line with this declaration. I guess let's hope for that if you're an author. Don't believe the hype. I don't know who that's written for. There's currently a strong commercial incentive on the part of the technology industry to overstate the capabilities of their products. Consult with experts, including mathematicians, informing policy decisions rather than relying on press releases or popular reporting of mathematical results. Regulate the artificial intelligence industry. This is probably the most important one. On this whole thing, this is like the one where I was like the most for that this declaration came out. Recent developments continue to highlight the strong public interest in regulating the technology industry. For example, in regard to involvement in military and mass surveillance programs. I'm not so sure. And then development of technologies which promote misinformation, undermine democracy. That one's like a blatantly obvious one. And then environmental costs is like there should be some research done, which I think has not been open. Definitely the pop-up data centers that are being allowed to exist in a lot of places are probably environmentally costly, and there's just not a lot of people that care about that. I think I'm lucky right now where I live in a place where there are a bunch of wealthy people, and there's a bunch of beautiful environment around, and the wealthy people care about the environment. Living in California is nice in that regard, where like there's still negatives, and there can be negatives, but there's a lot of beautifully maintained natural resources, just parks and huge trees on the ocean. It's not the same if you live in Utah and then someone wants to build a data center the size of Manhattan. Yeah, I think significantly increased public oversight is like a very important thing here. You could go as far as to say that like in the recent anti-monopoly legislation, it's not legislation, but like in the recent anti-monopoly lawsuit against Google, like they should have really been a lot more grisly with how they actually punished Google for being a monopoly in this one particular case. There's definitely a lot of like, it was very obvious, it felt like, that it wouldn't go nearly as far as it should have. But in retrospect, right, there's probably a very solid argument that the problems that a lot of people are facing right now, societally or like on a day to day in their technology ecosystem, which is where a lot of people get their news, spend like 4 to 6 hours a day just looking at the phone. Like a lot of these problems, you could make an argument are around because of the just like prevalent monopolies of tech companies like Google or Meta or Amazon. Like it is shocking that regulation is so lackluster. I mean, it's maybe not shocking, but it's disappointing. Definitely having some amount of competition you'd think would have provided good benefits that you just don't see um, because of the existence of a lot of these monopolies. And if you really like the convenience of Google telling you when your flight is about to leave because it connected your email to your phone, which was a Google product that's running on Android, that is useful. But just imagine how much more useful it could have been to have um, an ecosystem where I don't know, people have a standard for how they actually can interact with your device. So if someone wants to develop, they can develop universally for an iPhone and an Android, and there's not like a problem when you want to send a text message between one and the other, um, or imagine if you actually just had options for the services that you had, and people had to be competitive about it. So Google search didn't degrade in quality because the algorithm said present day information is more important than information from 3 months ago. I mean, I've completely given up on looking for things that I remember from the past. I think that happened years ago, but um, you can, if you've been alive for more than 10 years, see progression in some of these ways. And it's definitely my personal opinion that reintroduction of competition is not a bad thing. So recommendations for commercial artificial intelligence. While the mathematical community is recognized standing in academic and public policymaking, it has no comparable role in the corporate decision making that is playing an increasing role in our discipline. Nonetheless, recent developments have drawn mathematical work into industrial artificial intelligence efforts in multiple ways. One is through the use of mathematics to advertise the capabilities of commercial artificial intelligence systems to the public in communications and public relations campaigns. Public communications and public relations campaigns. Another is that artificial intelligence developers have increasingly used mathematical publications and formal mathematical libraries as sources of training data, not only for specialized models for mathematics, but for more general purpose artificial intelligence. And if those two things are correlated, like if artificial intelligence gets better, the more math that it knows, which doesn't have to be true, but if that was correlated, um, even by public opinion, the public thinks that a model is better if it's more capable at doing math problems. Um, then I feel like there's a strong claim there that like any revenue that is generated should be distributed to the corpus of data that um, was used, the corpus of mathematical data that was used to train the model. And there's a caveat here, which is like I could be wrong, right? Also, that like all of the training data could have come from completely transparent sources. Like these data collection companies did come up where they were paying people for solving problems, like mathematical problems. Like you want to solve a calculus problem, pose a problem to this AI that it can't solve, write the solution. We will pay you. Like I tried doing these for a little bit and decided they weren't worth it because you get paid like $60, quote unquote, for a question, which would only take 15 minutes. But because of the stupid UI of the company, or like um, maybe even just like the process that they wanted you to actually submit the work through, or the non guarantee of work actually getting rewarded based off of you think like some other reviewers opinion, which is not always a good one. Um, like it just ends up not being worth it at all. Where like the $60 an hour mark could go down to like um, $10 an hour, $20 an hour, or even if let's say the number was like $200 an hour, you're getting paid $200 an hour, and all of a sudden you're only getting paid $20 an hour because you have to fill out 9 steps and outline exactly which part was changed, and then the AI model generates another thing, and then you have to change another step of these 9 steps to say this is where the error is. Um, it just ends up not being worth it in the long run. So like, okay, if those companies were the ones providing all of the data for training of these AI models, then like more power to them. They did it. They did it righteously and got the bag. But I mean, God, even some of those companies were scamming where they were like paying people for work that they had done at a previous job, but they were only paying them for the process of like submitting the work. So you do some work, you produce some like documents that are like not important, and then upload that. Um, I think that's crazy, but I mean, you could just go on to LinkedIn and browse through the types of data annotation or whatever it was called, and see all of the crazy schemes that people were pulling. What currently makes mathematics attractive for general purpose artificial intelligence development is that the correctness of formalized proofs can be checked automatically without the need of human oversight. Makes it possible to generate and check vast numbers of problems, both human authored and computer generated, to produce an effectively unlimited source of feedback for training artificial intelligence models. The rationale for this strategy often rests on a further assumption that capabilities developed through mathematical theorem proving will extend to broader general reasoning. Some of the resulting general purpose models are being commercialized for applications that raise grave ethical concerns, including those named earlier: warfare, oppression, mass surveillance, and the undermining of democracy. Those like individual problems that, like, independent of mathematics, humanity and society should be concerned about. It's too bad that there's like a rise in fascism everyone's okay with right now, but we recognize that industry has offered lucrative jobs, monetary rewards, computing resources, and intellectually stimulating opportunities that some mathematicians have found attractive, like infinitely more attractive than academia in some ways. Um, Infinitely in some ways. This has taken place in an era of underfunding of higher education and precarious academic employment. That's the infinite part, right? Like, underfunding of higher education is equivalent to being poor and moving 14 times in 10 years. Like, how much money do I have in my savings account? Finally, it's like more than $0, and it's just because we like the union negotiated a huge contractual raise after we already had a huge raise from the university system that I work at currently. Like, if that hadn't happened, then I would just be poor. Still, I mean, it's significantly less than where I want to be at, and it's significantly less than where my peers are at. For those peers that graduated from a university after going to college, so like I make significantly less and have significantly less in savings than most of my friends that graduated with just a bachelor's degree, and that's regardless of career orientation. I mean, friends that I have in the same position, age wise and like say relationship wise, a lot of them are just further ahead in life because of my decision to go into to academia. That's how it feels. Or whether it's the fact that like I'm not sure if I'll ever be able to afford a home, partly because the cost of living around universities is just so astronomical, but also because I have zero savings, is what it feels like after being in academic employment for most of my life, which was precarious the entire time. Every year, it's like, okay, let's go through the rigmarole of sending out 100 applications to be rejected by everyone, and then like eventually beg for an extended position at some contractual position at some university. Um, I I think I've been incredibly bitter about this system and the way that I've gone through it, but I don't think that I'm alone in that regard. I mean, a lot of the postdocs that I've talked to at least can share similar experiences. Okay, so we also recognize that many mathematicians did not expect their work to become entangled with social, ethical implications of such magnitude. I think that's probably true. Um, whether or not that's right for it to be true, nor to be incorporated into systems used for purposes they might find deeply troubling. I think that to some extent you could say this about everyone that's been on the internet. Like everyone that's on the internet that's produced something on the internet doesn't have a clear understanding of like how their field has become entangled with these social and ethical implications, and they had no idea that it would have happened like this. I think you could ask like artists, people that have put a bunch of their digital art or you know musical people that put a bunch of music onto YouTube or something. You could say like I think a lot of people would think it's deeply disturbing and really kind of crazy how their work has become entangled with all of AI. Like, did they put up their work so that people could see it and enjoy it, and then that became a tool that could then generate work, and not only generate work, but also maybe generate political deepfakes. Yeah, I don't know how many people expected that, and you know, one of those things where sometimes it's just difficult to predict the direction of progress, I guess. Who would have guessed AI would come out and be so effective at generating information related off of its training data? While there was also, let's say, like a huge industry that had just been developed to aggregate and ingest training data from um, public domain. I don't know. We call on collaborations between mathematicians and industry to abide at minimum by the standards we expect our colleagues and that are described throughout this declaration. Such collaborations must respect the freedom of conscience of employees or contributors to speak openly about corporate policies and priorities. I don't think I'm going to read any of the institutional endorsements or the featured endorsements. Some of these are interesting. Terry Tao has an interesting perspective always on the large language model ecosystem and how mathematics will develop with it. And then these people, everyone here is pretty much famous, right? I can't recognize everyone's name, but like Peter Schulze, very famous mathematician who almost certainly doesn't use computers. Kevin Buzzard, very famous person that does use computers. Steven Strogatz is a very famous person also that is also a very prominent YouTube. I mean, I don't think he does the YouTube, but he shows up on YouTube enough where you can go look for him and he'll just show up in a 3 blue 1 brown video, for example. I mean, and he's fun to listen to. And then there's personal comments from people and that sign this documentation or this document. I think my general opinion of the overall Leiden Declaration on Artificial Intelligence and Mathematics is that I think I actually took much more of a positive view towards it after this reflection. My initial reaction was that I was a little bit bitter in some ways about the current state of academic affairs, and then the suggestion that like we should really try to maintain the current state of academic affairs to the best that we can. But on the rereading of it, I actually don't know if to what extent it tries to make this claim. So a lot of this declaration, it sounds very reasonable, and it's probably in mathematicians' best interest to try to maintain the amount of responsibility that you feel like you have for the field, and try to you know be better about the communication that you have with the importance of mathematics, although that's really difficult. And then I guess you know you can find interest in related fields, you can completely ignore it. I think it's kind of interesting. I'm definitely going to be using AI, I think, going forward, um, in a lot of different ways to help me with computational things, to maybe even, do some of the programming for me, try to reduce the timeline on projects that I don't think have to be exceptionally well developed. Um, I know that it's probably frowned upon to say that a lot of times when you write papers, you're not trying to construct a code base that you keep well maintained for all of history. A lot of times you're just trying to like get it done and then move on. And it seems like AI is pretty good at that. I think that it's definitely going to be a challenge to say all of the things in this declaration are going to hold true. Like, I don't think, for example, the incentivization structure of academia is gonna be constant, and there's gonna be a lot of change. I don't see it as a bad thing right now, maybe because of how bitter I am at the academic landscape in general. But there are people probably out there, my advisors, people, my colleagues, that have a better opinion even of just after talking to maybe people even in the other natural sciences who have gone through such a transition, like what those people complain about on a day to day, or what they complain about was like problems in their field. Like maybe there are other people that can see like how bad it is there, and they would say this is worse. What those people have. And if that's the case, then we really should try to maintain the shitty broken system that we already have. But okay, if you actually got through that whole thing, congratulations to you, and thanks for listening. That's my whole opinion, reaction to this. So, peace out.